And welcome back to the second part of today's lecture, which is lecture 1. And after all the org-related information now, getting started with the real content. This is supposed to be a little bit of a motivation introduction session. It's a little bit longer slide set, so we might blow a little bit above the timeline, but as I said afterwards, there's not really an exercise session, so you will make up for that time. To get a little bit of a better understanding about our audience, I would like to first get, we have some questions like, how old are you, what are you studying? So I would like you to please join the BBB room. Teresa, my support hero in the background, already posted polls there. And for the first one, we'll wait a little bit longer so that everyone has time to join and then provide an answer. And then getting a little bit of idea of who's joining. I think last semester we had someone who was like 55 or 60, which was a little bit of a surprise because we didn't know like everyone in the BBB room. So this is why we're also asking for age. For most of you in the audience, I have a feeling how old you are. But especially since we're scaling up, I'm really interested like who's joining. And if someone is taking up this offer of joining us without having to do credits or without wanting credits, just like for the sake of getting the knowledge or participating in this course. Everyone already on BBB? Yes? No? There's a little bit of head shaking. I would say 15 more seconds. And then Teresa can close the poll. Good. I think it should give us an idea. So, okay, so the first column are the answer options, and then, okay, we have 2 people. It's a really unfortunate format, but okay, 2 people who are 23, but a range from 19 to 29. 34, great. That's not bad. I'm not the oldest here. No, this is not why I'm asking. Good, so young audience, no one in the 50s or 60s as last time, but it's not just early 20s. Thank you very much. Next question, where do you study? Let's say the Digitech students, since I'm a TU Clausthal professor, please answer TU Clausthal. So that you can, that you don't have to think about which university you like more, you just can by default decide that you are TU Clausthal people. So almost everyone. Clausthal, 1 Westphalia, very good. Göttingen, 2 people, great. And other not a student, also not bad. That means we have at least 1 highly motivated person who is joining us outside the university context, or a different university. Very, very good. Good, thank you. Next, I think there's question number 3. What do you study? Because I know that there should probably a lot of Digitech students here. To maybe simplify that, because digital technologies, including spelling mistakes, has a lot of different like ways to answer. Let's say DT is Digitech students. Very good, capital, please. Very good question. Go, 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 go. Come on, I've lost slides. Ah, VWL, not bad. And Digitech still. Yep. PhD student in tropical forest ecology. Really cool. Industrial engineering. I mean, DT is also cool, don't get me wrong, but I expected that because I know that most of you study DT, but I'm really cool that there are also like different studies. I mean, of course, we would like to have way more students and way more diversity, but very happy with that set. Good. Question number 4. I think there are 2 more questions. It's a little bit of a subjective question, but the bottom line being, you've probably heard that climate change and environmental pollution is not something that really fosters a long life for you. It has a major impact on what you can do with your life and your future. And the question is essentially, do you think we're already addressing that properly, or like just on a personal level? Are you happy with that? And think that's okay, or would you like? Do you always already have the feeling like, nah, I'm not happy with that. I would like to have more, or no opinion is also okay. Like if you say I don't know enough about the topic, that's why I'm here. So don't ask me that stupid question. As you see, it's an anonymous poll, so we don't see what you answer. We also don't want to know who answered what. That looks weird on my screen because the question is so long. Okay.
So it's basically 80% said no, and 20% said not sure, and nobody said yes.
So no one is satisfied. Most of that you are not satisfied is okay. Good or bad, depending on how you see that. And last, I think it's the last question. Since a lot of you seem to be unhappy with the state of affairs, are you actively doing something in an organized context, on a political level, or in any other context? Of course, you don't have to answer. You can also just say, I keep that for myself for whatever reason. Just a curiosity question. No, okay. So that is easy, but also not a problem. So last time we had various people who were either involved with Fridays for Future or part of a political party. Not sure which one anymore. So there were some people, but no, it's also an option. I mean, you're full-time students. You're probably busy. Therefore, we're just asking out of curiosity. Good. I think that was the last question, if I'm not mistaken. No. Very good. That's a little bit of a legacy question, but also still relevant for those of you who are not Digitech students and thereby forced to be here anyway, or partially forced, because we know there are some people in the audience, in the online audience, and the question is, would you like to essentially be here regularly and do the Q&A live session online, or would you all? I mean, Digitech students can also say, would you like to do the Q&A session online, so that we just after the live lecture, we make a cut and then say, okay, you join from wherever you like. You can be here or not. It's essentially for us an org question. Would you like to do the Q&A live in Goslar, or is online also fine with you, or even preferred? Probably doesn't help you if you're in the public transport, I guess. Good, come on. We have to make up a little bit of time. That's that's not helpful. Okay, so we're gonna stick with the live one. We're still gonna stream it, but we stick with live. Okay, thank you very much. That's not really helpful. Good. Then if I get the presenter rights back, let's start with the actual content. And some of you have heard this short teaser presentation that I gave for Hannes' creative methods or Kreativtechnik, whatever the English translation is, lectures. And so some of this might feel familiar to you, especially since I recognize a few faces, but we're still going to do it as intended, especially for all those people who haven't seen that lecture or participated there. So please, if you know the questions to some answers, please act a little bit innocent to not spoil it for the others. Thank you very much. Good. And you also already know that we're probably going to talk about what the inconvenient problem is that we're going to talk about, because I teased it before, but it's also like you can derive it from the topics that I highlighted in the org slides, what we're going to talk about, like what are the foundations of climate change, environmental pollution, resource scarcity, and it pretty much boils down to this one single inconvenient problem that we're having, and this is essentially that we only have a single planet, and we are right now pretty much ruining it. If we would have more planets, no problem, we could just move on, no problem. But even if Elon is super happy and motivated about his rockets, it's probably not suitable to get 8 billion people off this planet. So we probably have to stick with this planet and make something work here, or otherwise it's just over for us. And you might have seen this figure before. It is just like one way to highlight a certain subset of those problems that we're going to talk about very much detail in this lecture, which are the so-called climate change related global greenhouse gas emissions. We're going to talk about what climate change, the definition is. That's up for the next lecture. We talk about greenhouse gases, what are the definitions, what are examples for greenhouse gases, and what are emission pathways. This figure now just for like very simplified example reasons. So what you can see here is on the left side of the scale, how many gigatons of CO2 equivalents we emit on an annual level. So 100 gigatons of CO2. On the lower scale, you have time, essentially, 2000, 2020, 2040, 2060. And then you have different pathways, different options. Depending on what we do, we will end up with different pathways. So depending on how much CO2 we're going to emit after this breaking point here in 2019, this is where the figure was created, we have different options what's going to happen. So the more CO2 we emit, we go up in temperature pathways. The less we emit, the lower the temperature is. What the relationships between greenhouse gases and higher or lower temperature are, we'll come back to that. For now, more greenhouse gas emissions means warm, lower greenhouse gas emissions means less. And most of you have probably heard of the 1.5 degree global warming goal before. This is what more or less the majority of politicians agrees to follow as a goal. But then there's a huge difference between what they promise and the actions that they undertake to get to that goal. Because if you look at those pathways, we have like this 1.5 degree goal, which is dead by now. We'll talk about that later. We have then the 2 degree goal, which also is not that safe right now. And then we have another pathway in yellow here that is what would probably happen if we do what all the countries or all the nations at the Paris Agreement agreed to do, which was back then, we'll come back to this historical parts a little bit later, but back then they were like, this is a huge success, we've made something, we did something. But even what they promised there, what they deemed to be ambitious, somehow far away from 1.5. If I'm not mistaken, 2.8 is almost twice 1.5, but I wasn't really good at math. And when you're looking at the current pathway that we're following, what we're doing right now, we're even above that. So we thought Paris was ambitious, but we're still not getting that done, even though we would need to do way more to get to 1.5. So right now, if we continue with the greenhouse gas emissions as we do right now in 2019, and I can tell you it's just gotten worse, we're probably ending up with something like 2.8 to 3.2 degree global warming, which is still better than not doing anything, because the not doing anything option doesn't sound really much better. And what the difference between 1.5 and 2 degrees or 3 degrees is part, I think, of the next lecture, where we'll spend, I don't know, at least 15 or 20 minutes just looking at examples of what those half a degree, 1 degree, 2 degrees difference will mean for you living on this planet, in very specific examples. So 1.5 is what we would like to get we can already see, okay, we're probably not getting there. So how high can we go? How much can we fuck up? I mean, this is also what you're probably doing in an exam. Okay, I want to get 100 points, but how low can I get to still get a good grade or to just pass? So what are we now optimizing for? So what's the upper threshold that we can, that we should not touch without getting into any problems? Unfortunately, I cannot give you an answer to that because, at least to my knowledge, there is not really a consensus on how high we can go. There is a consensus that everything up here is super, super uncomfy, but there's like not really a lot of hard numbers or facts. But some scientists are willing to give some estimates. And one of them is Michael Mann from the Penn State University. I think it was Penn State in the US. And he made the statement, or he said that he would probably advise us to stay below 3 degrees, because this would cause conditions to those to where we can adapt to. So the changes that would be caused by 3 degrees on a global level are probably within our adaptive capacity as a society or as a civilization. 2.7 would be better, because after 2.7 it's already a great hardship. So it's not like we can survive maybe, or we can maybe adapt as a civilization, but it's not really fun. So that means, or it implies also, that more than 3 degrees is possible, but civilization requires a certain level of complexity to work. For example, global trade. You don't have global trade, and you don't have fancy iPhones anymore. You might not even have toilet paper anymore, as you might have discovered during COVID. So yes, you can maybe survive, but civilization depends on complexity on a global scale. So it would probably be even less nice if we hit that. But this is just like a rough estimate. This is not written in stone or anything. This is just to get you a feeling of where the upper threshold is that we should not touch. If it's 3.1, 3.2, 3.0, 2.9, that's not really the point here. But essentially, we get a little bit of an upper ceiling that we should not touch. And even though climate change hits, or environmental pollution, climate change, and other problems hit us here in Germany, most of the consequences so far have been rather in countries that we might visit, especially we being here in Germany as German students, that we might visit or have heard of in the news, but they're not really, it's not something that we have experienced for quite a long time, but even that is now changing. So those images are, I think it's from the Ahrtal just a few years back, where a flash flood caused quite a lot of damage. And the intuitive solution now was to just implement some safety measures so that warning systems work better, build a little bit of a higher dam, or try to figure out some solutions and then just rebuild everything. After this lecture, we might question whether this is really the solution, because the weather is not just getting like more rainy or more sunny, it's getting more extreme. That means those extreme events will become more regular, and the peaks of those extreme events will become more and more of a problem, even here for us. So it's not just something that's going to happen again and again somewhere else. It's also going to happen here, and we'll have more examples related to very specific our situation. The opposite of too much water being too little water. That is actually the example from the Okertalsperre, just a few kilometers from here. Right now it's quite nicely filled. So there's, I think, like 70% of water in there. But this was, I think, if I'm not mistaken, 2021, the end of 2021. So it varies heavily. So there was so little water in there, they found old parts of the old buildings that they drowned in that lake to build that dam. So there was a like small village before, and there was so little water in there that they found like all the stuff that was left behind, and because the water dropped so heavily. And you also noticed that maybe in the past summer that there were parts in Germany where so little water that you had problems getting rid of wildfires or even securing sufficient amount of drinking water in various parts. I've been to the south of France recently, and especially in the south of France, like it's a lot of like wildfires, but there are not only wildfire problems where they need a lot of water to combat them, but they also have problems with water distributions. There were various towns where they had to bring water in bottles to those towns because not enough water left anymore. And even though this is like a partial problem, becomes more predominant the more we struggle with these consequences of climate change and environmental pollution and other factors. Funny side note there, France is always very happy about their nuclear reactors because they just work very efficiently. But water is a fundamental part of running a nuclear reactor because you need it to cool down stuff. France has so many reactors, but so little water supply, or like a very fluctuating water supply, that they are now trying to figure out plans on what to do if there is not enough water in those rivers relevant for the nuclear power supply anymore to keep them cool, because you need a lot of water to keep them cool. And if you don't have enough water, they heat up and you have a problem. Same applies to French agriculture. They also need a lot of water for that. And when we've been in France, we've drove through various parts where they had active wildfires. And as a consequence, you couldn't get coffee at gas stations next to the highway anymore because they cut the water supply so that they had enough water to fight the fires. So too little water, too much water, both problems, and both will be more normal in the future due to climate change. I mean, this is just the final consequence. No water means death. But also something related to too little water, too much water, too little sun, too much sun in terms of heat is related to our secure and resilient food production. Because right now you're pretty much used to just go to the supermarket and get whatever you like, except for like very seasonal stuff like, I don't know, Christmas chocolate or whatever. You can pretty much go to the supermarket 24/7, grab something you need, go. But this is something that is not really. First of all, it's nothing that has happened like or was stable for as long as you might think, because this is quite new in terms of human history, but it's also not as secure as you might think. I mean, some of you have experienced already supply chain disruptions during COVID, not just the toilet paper, but also various other articles have been available in less quantity, and it was more problematic to get it. Food wasn't a part of that yet, at least not besides any kind of specialized food. But if you don't have enough water, you have a problem. If you have too much sun, you have a problem. If you have too little sun, you have a problem. So those could actually become quite a problem very, very soon, because on a larger scale that we use those resources, it makes a difference. So I think this year was one of the worst years in Irish potato farming history, because weather was too fucked up. If you get just one like super chilly night at the beginning of the year, all your fruit trees lose the fruit, ihre Blüten, whatever Blüten of English is, sorry about that part. But then essentially your whole harvest is gone for the year. If the Blüten get chill, like a chilly night, just at the beginning of the winter, you're done. And the same goes for dry spells, and then you have a problem. So we don't think that this is really a problem, but resilient food production is a huge, huge problem, especially if you think about where most of our food comes from. We have a lot of agriculture in Germany, but most of our fancy food stuff comes from somewhere else, mostly south of Italy or south of Spain. But if we go to 3 or 4 degrees global warming, then the south of Spain or Italy will be more like Dubai or Saudi Arabia. And those are not really the places that are most famous for very productive agriculture. So we have to get that food from somewhere else. That means less and less space for us to grow food for more and more people. Wildfires also not really contributing to a resilient food production, but also causing further problems. First of all, by burning down buildings and people or animals, but also contributing further greenhouse gas emissions and causing a lot of damage to ecosystems. Sure, this is now not from Germany, but we had enough wildfires in Germany, especially in the eastern parts like Mecklenburg-Vorpommern or Brandenburg. And this is also going to be a dominant problem that gets more and more critical in the future, and I've already talked about France recently in this summer. Another problem that might not be as relevant to those of you living here in Harz are rising sea levels. And we might not really experience that as drastic changes, because usually we're talking about sea level rise of 1 millimeter or 2 millimeters or 3 millimeters. That will also have a serious impact because a lot of large cities are very closely located to the sea. But another problem that is more dominant are so-called flooding events due to storms. So a flood that is supposed to happen once every 10 years or 20 or 40 or 100 years suddenly appears once every year. I have to check if it, also to briefly answer Laura's question, I don't know which word I just used. If I said in history or in recent history, I would need to look it up to be honest. But Teresa's probably going to take a note, and then we'll figure that out and get back to you with a precise note. I have to be more careful with my wording. Thank you very much, but we'll look it up. Good. Sea level. So sea level rise in itself, more problem due to storm events that then. We just had it in a few weeks ago at the Baltic Sea and at the North Sea. Various dams broke. What do you do if a dam breaks? You repair it and just make it 5 centimeters higher. I hate this pointer. But what's the problem? Okay, I built this one, it broke, I make next one, slightly higher. Then sea level rise continue because glaciers are melting, weather is changing, next hard storm hits. So breaks the dam, I build it higher. This is a very, 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 very expensive process. It takes a lot of time, it takes a lot of resources, and you always have to make those dams much, much bigger. And the problem is usually we cannot really keep up with this. And if you look at the Netherlands, which are in certain parts, I don't want to say most or larger parts, but there are like a lot of parts of the Netherlands that are below the surface, it gets much, much more difficult to defend those places. And especially if you have like cities like New York or Bangladesh, not this as a Manila, no, not, what's the city of, what's the capital of Bangladesh? No help from the live audience, thank you very much. But Bangladesh has a capital that is in a very flooding-prone area. So just to make my point, usually capitals or cities are not designed to like around flood protection. Usually you build a city and then you notice, oh shit, it gets wet here. So you build an extra dam, but they are not built in such a way that it's easy to defend. So now you have to figure out ways to defend them. Dakar, thank you very much. Laura is my savior. So you cannot just continue this game again and again and again. Plus it costs a lot of money, resources, time, and energy that you might need otherwise. So just building higher dams is a game that eventually you will lose against nature. You can do it, but how high can you build? Like, where's the limit? 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter extra, how much can you afford to do? Until you run out of resources, time, money, or space to just do that. So all of those examples that I gave so far are essentially just either extreme weather events in themselves or implications or side effects of extreme weather events. And I already briefly mentioned that this will become more normal, and that what we've seen in Ahrtal or the droughts this and last summer, and then sudden heavy rainfalls followed by another drought are not things that will remain rare events, but rather become more dominant. One of the reasons being climate change. We'll get to that connection between those extreme weather events and how climate change causes that in the next lecture. But this is pretty much why we got into this mess. And right now we are taking every storm, every flood, especially if you look at hurricanes, for example, in the US, they are very happy to just rebuild everything once a year or once every 2 years. Hurricane comes, your house is gone. You still have that property, you build the house again, 2 years later, your house is gone again, and you do that again and again. This is all what they have already, and if it becomes more dominant, then you pretty much can't give up there, because you can also just not afford these resources anymore that you have to put in that. So extreme weather events becoming more dominant and more regular, and instead of a 10-year flood that happens once every 10 years, you suddenly have a flood that happens once every year. And the once in a lifetime flood that should happen, I don't know, once every 100 years, suddenly happens once every 10 years. You have to deal with those consequences either by ignoring them and just letting people die and say, okay, it's not safe to live there anymore, we just go, or you have to put a lot of resources and effort into defending against those new problems that we cause there. But no matter how much energy you put in that, some parts of the world will become less inhabitable or even uninhabitable, because we as like people from countries that are very well off financially from economic perspective, we can put for some time a lot of effort and resources into protecting us and adapting to climate change. But there are enough places on this planet where this is not really an option. So you just have to leave. You cannot spend a lot of resources and time defending against climate change anymore. So less space available for the same amount of people on this planet, which means more people per square meter, and you have to care for them under extreme conditions, which will not only cause social conflicts, because what we can already see, like people migrating from parts of the world where it's not really fun anymore, or this will become like a more dominant problem, not just for economic reasons, but also for ecological reasons. And you still have to figure out how do you do that while having to work under restricted environments, like less space to grow food for more people, quite challenging. More space to store, less space to house the same amount, or more people, you get the idea. So essentially, you have less from everything, but you have to take care of more on the same space. That's going to be one of the major challenges here. And no matter if you believe in climate change or not, this is not a talk or not a lecture to discuss whether climate change is real. It is, thank you very much. But no matter if you believe in that or not, especially in the US and other countries, there's like a very lively debate from various politicians if this is real or not at all. It doesn't really matter if you believe in it or not. It's coming, whether you like it or not. And if you don't think it's relevant, it's still coming, and you still have to adapt to it, or you just go extinct. I don't know. What's your plan? And this is like one of the challenges part, climate change. The problem is there are more. In the short teaser lecture that I gave for Hannes' course, we also talked about environmental pollution. Most namely, the example right outside this lecture room, where we have the legacy of a very old mining operation for hundreds of years of mining different types of ores and whatever that came out of the Rammelsberg. What we have now here is a highly contaminated and polluted environment where you can grow food, but you shouldn't eat it. That also being the reason why there is no green trash bin here in this part of Goslar, because even the grass that you cut here is so contaminated and so polluted that you cannot put it in the compost. So great. If you now think about that in the context of how we treat our environment with respect to further pollution, because we're not really like scaling down on pollution, that just means that less and less space remains available to us to combat those issues that we just highlighted for climate change. So essentially, it's yet another component that makes sure that we have less and less and less available to care for more people. So polluting our environment, either the soil, the air, or as in this picture here, I hope you can see that there is a trash truck here. And I think I brought it from Greenland. That's near Upper Narvik, where the solution for trash handling here is finally keeping it on land. But before, they just reversed to the next fjord, and then they just dumped it in the fjord, because if you cannot see it, it's not there anymore. And this is one of the most fragile and beautiful ecosystems that you will ever see. The solution was just to dump it in the ocean. Polluted ocean, polluted soil, polluted air being among the other problems that cause some trouble. I think some of you might already know the answer to that questions. 3 of the 10 dirtiest European coal plants are located in Poland. Where are the other 7? Taking guesses here. Come on. Nope. Laura got it right. Germany. But maybe Laura skipped ahead for the slides, but I don't know. I don't want to make claims. No, but Laura got it right. Germany is the correct one. How much land mass is taken up by trash currently? No idea. Wait, there's the video. No idea, sorry. But also interesting question. How much land is taken up by trash currently? One note, please, Teresa. Maybe I'll find something, but honestly, no clue. No clue yet. Back to the coal plants. So Germany, as one of the supposed leaders of the green revolution when it comes to regenerative energy and other stuff, is still operating some of the most dirtiest coal plants that we have in Europe, and we're not in the process of shutting them down. There are various reasons why we still do that. Not going to open a discussion on why that is the case, just highlighting that even those who claim to be at the forefront of the green revolution still have a lot of dirty clothes to wash in their backpack. Environmental pollution in context of barren land. We talked about the pollution of land by just putting stuff in there that shouldn't be there, whether it's heavy metals, or if you go to agriculture where you use pesticides that stay there for a long time or go into the groundwater, whether it's some kind of fertilizers. If you want to get a home near to train tracks or highways, you can always go left and right and find a high amount of pollutions from just all the exhausts, the rubber, and all the stuff that they used in operation of those train tracks or the highways. So there's already something polluted. Then you also have the problem that if earth is not, or soil is not managed properly, it degrades heavily. So for example, in agriculture context, if you have a farming field that is not covered, rain drops down, it washes away nutrition from the soil quality degrades, you need more soil or more space to grow the same amount of things. So essentially, land becoming less productive because you're washing away relevant parts of that other soil that you can use to grow something in the first place, but also you're washing off nutrients. Very shitty. So it's not just that we're polluting what we have left, we're also degrading what we have left without pollution. Just to name a few examples here. I think someone mentioned being a student or a PhD student of forest ecology, and that student could probably expand on that easily for another hour or so, but forest ecology, or I'm not a farming person. We do resilient farming in our research group, but I'm not a farmer, so not claiming any level of expertise knowledge here. Another aspect that we often, or is often associated with environmental pollution, but also with climate change, is the extinction of various species. Could be just the poor polar bears that struggle to find nice places to live, but also just other types of species that are threatened to be extinct. So we have roughly 8 million species, most of them being insects. Up to 1 million species are threatened with extinction, many within decades. And you could say, look, this is not really my problem, but for example, those guys are in charge of pollinating your supposed to be food on the farm fields. If you don't have someone pollinating that anymore, you have to do it by hand or with machines. It causes yet another set of resources that you have to spend or to use. And of course, it makes it way more complicated to just grow your banana if you have to pollinate everything by hand. And those side effects are often not really considered. If you think about it, like mass extinction, yeah, sure, one polar bear less, a few bees less, one of those insects, they are annoying anyway, so you don't really consider those as side effects that can have serious impact on what you are doing here. And finally, one of my favorite topics, resource overconsumption. Who has heard of the Earth Overshoot Day? Some hands, yeah, okay. For those of you who don't know it, pretty simple. The Earth has a set of resources, and some of them can be regenerated every year. So like if you cut down a tree, it's after some time a new tree grows, so you have a certain amount of resources that can come back every year. And the same could be simplified in a simplified manner, be said about how much pollution you can handle. So some amount of pollution can be absorbed by the ecosystem. The planet can make up for that, but you cannot make or cause too much pollution because then the ecosystem degrades and breaks down. So there's some level of things that we can take from the Earth per year from the planet. That's usually, like, in simple terms, called the biocapacity. We'll get back to a proper definition later. But for simplification reasons, essentially, how many resources can we extract from the planet per year without taking too much, and how much pollution can we curb without breaking down the system. And intuitively, you would say we should limit ourselves to just like this set of resources or pollution that we can make up for in 1 year. More would be stupid. It's the same as spending twice your paycheck every year, not every year, every month, because you just have one paycheck. Nevertheless, what you can see very nicely in this figure is that we're doing exactly that. We're spending more or less 1.5 paychecks per year. So initially, when they started this figure in 1970s, we almost made it to the end of December with the resources that we used in that time frame. And then over time, the red part becomes more dominant and much, much bigger. And I haven't checked today when we hit the Earth overshoot day this year, but obviously we are in November, it's long past. And if everyone would live this way, or the way that we're living right now, we would need 1.75 planet Earth, last time I checked. And what was also motivated by this inconvenient problem that we talked, we only have one planet. So we're using 1.75 planets while only having one. And if you would do that with your paycheck every month, you would get in trouble very, very soon. But for whatever reason, we don't really give a damn shit if we do that with our planet, despite the fact that we have been told that this is a problem. And having too little resources at some point causes problems. I mean, this might now be an image made to create or to make a statement with a dramatic theme. Nevertheless, it's not that wrong. Climate change, we already said, causes us to have to move together into a smaller space. So there will be conflicts about that already. If we then also are getting problems with how many resources we have left, more and more and more problems. So it just causes a lot of conflict potential. And it's not like we haven't seen wars for resources before. Wars for oil have been happening for quite a while, since we started digging up dead dinosaurs. Same is true for certain types of metals, or other, like just farming land have been very nice examples where we have created, or where we have started war after war. So this is not something that is so unlikely or unrealistic. We have done that before, just not with a clear intention or the clear statement, we're gonna fuck up your country because we need your resources. Usually you find some kind of other claims or justifications to start a war. But usually it's not about this official statement of war. But this is gonna be a way more serious threat for the future. So, to wrap up now a little bit, 3 key challenges that can be derived from those examples that I just gave you. So first, we talked about climate change and the challenges of adapting to climate change, because we cannot stop it anymore. We can try to limit climate change to 1.5, 6, 7, 8, 9 degrees or 2 degrees, but stopping climate change is out of the question. We're not getting back to 0-degree global warming. That's just not how that works. So we have to adapt anyway. Adapting can mean building a higher dam. Adapting can mean shutting the borders so that less people can make it to where we live right now. Adapting can mean new cool technologies that will help us to survive. Adapting could also mean to say, look, we don't need a new iPhone every year. So there are different ways of adapting, and those are some of the topics we'll talk about later. Environmental pollution, essentially just contributing and worsening those challenges that I just highlighted there, because it makes the available space even less resources available, making that mess even more problematic. There is a fourth component that we will probably build into this lecture step by step, where we have the social conflicts and the social conflict potential that also plays a crucial role here, that mostly poor people will suffer from the consequences the most. It's not Elon Musk who will suffer from climate change, environmental pollution, despite the fact that the rich people are among the heaviest polluters and users of resources that we have on this planet, but they are suffering least. That, again, causing further conflicts, but also those conflicts that we highlighted due to wars about resources or just space to live that I briefly teased before. We'll get back to that part later. So we are slightly over time, so I would now make a cut here, and we're gonna continue next week, because I think next week I have slightly less slides, so I have a little bit extra time. So that's lecture one for today.